Assalamu alaikum and good morning everyone. In this video, I'll be explaining my embedded system home task where I read an analog value and then from the potentiometer and using the ADC and then display it on the LCD. I'll be explaining all the code we have learned in this lab. First of all, I would explain you this from the top like this. If and f underscore CPU, this is the clock frequency here. Then from here, our code starts. This is the map of the LCD. Then it's wait a second. No, sorry. This is the map of the LCD and the data pins D0 through D7. Then after it is the RS and the enable. RS is in port C6 and enable is in port C7. This tells the LCD library which microcontroller pins are connected to which LCD. Then after it is the header file library like AVR input output. Then it's for the delay library, and then it is lcd.h. lcd.h is the LCD driver library that handles all the low level LCD communication. Then it is unsigned character. uh, Here in int main it is unsigned character A10. This will store the ADC value after we convert it from a number to a string, and so that we can display it on the screen LCD. Then this is DDR F is equal to 0 cross 0 0. DDR B is equal to 0 cross FF. This is the port B. Port B we have declared it as a port B output, and then DDRC, it is for the output. Port C is output for LCD control, and F is for input of ADC. Sorry. Then it comes ADC ADC CSRA is equal to 0 cross 87. In binary, 0 cross 87 is like 7-bit sets of which enables the ADC bit 0 to 2, which are all ones. Set the prescaler to 128. Since our clock, as we know, it is as 16 megahertz, dividing by 128, which gives us 125 kilohertz for the ADC, which is within the recommended range. Then it's the while loop here. Zero cross. Wait a second. Sorry. This is the 0 cross 4740 here. It is in binary bits 6 and 7. Set the voltage reference to AVCC, which is 5 volts. The lower bit, like, which is 5 volt, then and the lower bit are 0, which selects the ADC channel 0. Then I here initial then I initialize the LCD 8 I net. Then here comes the while loop in AD while 1 AD CSRA is equal to 1 shift AD CS. This starts a single ADC conversion by setting the ADC bit. Then comes while ADCSRA and 1 shift ADIF, that is equal to 0. This is a polling loop. We wait here doing nothing until the ADF flag shows, ADIF flag shows. The ADC interrupt flag becomes 1 here, and which shows the signal that conversion is complete. Then ADCSRA 1 shifts ADIF. This clears the flag by writing 1. Unsigned int x, unsigned int x here. This reads the 10-bit ADC. This reads the unsigned int x is equal to ADC. ADCH shift 8. This reads the ADC result, and we shift ADCH left by 8. Like we shifted to 8 and OR it with ADCL to combine them into a single 16-bit integer. Like this is the OR gate, and when we shift it to 8, then we and or OR it with ADCL. Then it comes ITOA. ITOA converts the integer into a string stored in array using base 10. X is that value and A was that, and 10 is the base 10 with base 10. We use it because the LCD can not only display the characters, not raw integers. Then it comes LCD 8, set cursor 1 0. These lines these display the output on the LCD. Then LCD write string, it also displays the LCD set cursor 2 0. It shows these all four lines just display the output on the LCD. First one, set the cursor to row 1 and column 0 and write the label port, and the second one shows the port ADC. Then I move the cursor to row 2 and display the actual ADC on the value stored in the string. Then it is a delay of 50 milliseconds, and a 50 millisecond delay is added before the loop repeats, and then again this loop is repeated. Now comes the Proteus stimulation. No, first of all I would run this code from here by adding the lcd.h file. Existing item. Like here is the LCD file. It's I guess added here. Now I can build the solution. So here our code is executed, and we would break it, continue, stimulator, now main and debug it, step into. As our code is running, I will debug it and step into again. Now let me show you the Proteus simulation. Here comes the Proteus simulation. This is the LCD connected to each pin, like IO31, IO30, IO53, IO52, IO51, IO50, IO10, IO11, and IO12. This is the ground, and this is here. In this schematic, we can see the microcontroller in the center here, and the LCD is connected to 8-bit mode, and this is this is the potentiometer. We have connected it here. Now for running it, I would add the hex file here from this desktop on task 5. This is the hex file, and now let me run the stimulation. Yes, you can see now the port ADC shows IO23 here. We can see the potentiometer is connected with its two end going to 5 volts and ground, and the wiper, the middle pin, going to ADC or ADC 0, that is IO54. And when I run the stimulation, if I stop it and if I again run the stimulation and rotate the potentiometer, you can see the values on the LCD screen here. And here. This is now like shifting. If I add here or give the negative value, you can see it's changing the value on the LCD screen. So thank you so much for watching this video. I have explained whole the home task 5 on this in this video. Thank you so much.